We're now looking at expanding binomial products. Now we're looking at what these mean. Now what is an expression? An expression has one or more terms with no equal sign. For example, an expression might be this: 3x squared plus 4x minus 5. That's an expression. No equal sign. It's an algebraic expression. Now a binomial expression, binomial, two numbers. A binomial expression contains two numbers or terms. That's what a binomial is, okay? So what do you think a trinomial is?
Three.
Yeah, it's got three numbers. So this one up here, that's a trinomial, okay? So a trinomial has three numbers. And that's an example up there. Three terms. Three numbers or terms. 1, 2, 3. So that's a trinomial. Next lesson, we're factorising trinomial quadratics. Okay? Now, a product is the result of multiplication. For example, the product of 7 and 3 is 21. So today we're going to expand. Today we're going to expand binomial products. So we're going to have binomials, two numbers, and they're actually going to be in brackets. Now here I've just got one number outside the bracket, but we're going to be doing brackets times brackets, okay? So this is a binomial here. For example, 3 times y is 3y, 3 times 2 is 6. That's factored form, that's expanded form. Of course, when we expand an expression, we're removing the brackets, okay? But that's not expanding binomials. Well, that's doing one. But we're looking at binomial products. Now, what we want to do is, for example, let's say a rectangle has the area of y plus 6 times y plus 2. So to understand how to expand an expression, you can use the area of the rectangle to represent the product. For example, if a rectangle has length y plus 6 and width y plus 2, what we can do is split it up. Now, I'm only ever going to do this once and now, because the syllabus tells me to show you this way, but we'll never do it like this again. Y plus 6, we don't know how big y is, so y plus 6, y, as long as the y's are the same, plus 2. Now, to work out the area of this rectangle, they've broken it up into not squares, but rectangles and squares. So I'm breaking it up, and it's done down there as well. That's y times y. The area of y times y is y squared. This bit is 6, so this is 6 times y. Do we see what the diagram's about? That's 6y. This is 2 times y. In there it says 2y, even though you can't read it. And this area here is 6 times 2. Can you see that? Now, of course, we're not going to do it like that. We do it a much easier way. So therefore, y times 6 times y plus 2 would be the addition of all these areas. Y squared plus 6y plus 2y plus 12. Now, collecting like terms here, which are the y's, that would be y squared plus 8y is 12. So you can do it with rectangles, but we're not going to do it with rectangles ever again. The way we're going to do it is to expand binomial products. Now, this is a binomial product. It's a binomial times another binomial. All we do is we make sure that the y in the first bracket gets multiplied by everything in the second bracket, and the plus 6 in the first bracket gets multiplied by everything in the second bracket as well. Okay? So to expand binomial products, just multiply each term in the second set of brackets by each term in the first. Of course, to make sure you don't miss anything, you do it with a systematic method to make sure you don't miss one. So girls, again, this rectangle, x plus 5 times x plus 1. There's the x, there's the 5, there's the x, there's the 1. Do you want to write the areas of each rectangle? What have we got? Or square? X times x is x squared. X times 5 is 5x. 1 times x is x. And what's in this one?
5.
1 times 5. See, 5 times 1 is 5. So therefore, we just add them all up. It's x squared plus 5x plus x plus 5. Are we okay with that? Just doing the area of each rectangle, which is what? X squared plus 6x plus 5. Now, let's see if you can do the next one. I'm going to do this other way in a minute. And not even the other way down the bottom. We're not even going to end up doing it that way in the end. What do you think I've got here with the one with the 28? How do you think you're going to get the 28, girls? What times what? Yeah, 4 and 7. Let's see. Wouldn't you put X? We think that the 28 is 7 times 4. Tell me what the 11 is, girls. If 28 is 7 plus times 4, tell me what two numbers add up to give 11.
6 and 5.
Yeah, what about 7 and 4 as well? I just want you to notice that. 7 times 4 is 28, 7 plus 4 is 11. So tomorrow, actually on Friday, when we factorise binomials, that's what we're going to be doing. We're going to be looking at it to say what two numbers multiply to give 28. What two numbers add up to give 11. So we know that this is x. 7 times 4 will give me the 28. Let's have a look. X squared. What have I got here? What's that times that? 7x. What's that times that?
4.
Yeah, it's 4 times x, and that's 4 times 7 is? So it just says draw a model showing the length and width, and we've done that. And if we add those all together, x squared plus 7x plus 4x plus 28, isn't that x squared plus, they're like terms, 7x and 4x, 11x plus 28. Now, we're doing more of that tomorrow. That's more factorising. Today we're expanding. Now, when you expand, I'm not even going to make you expand like this either. This takes too long, and I don't like this method. But what we're trying to show you is, if we're trying to multiply y minus 3 times y plus 4, we know, as we said before, this y needs to be multiplied by each of the terms in the second bracket, and the minus 3 needs to be multiplied by each of the terms in the second bracket. But I never set it out like this. We're only going to do this here and not again. So this would be the y gets multiplied by the second bracket, and the minus 3 gets multiplied by the second bracket. Can you see that? But we're not going to do it like this anymore. So what's y times y? Y times 4. 4y. Now, don't put minus until we're sure. What's minus 3 times y? Minus 3y. And so I'm doing, I'm doing that times that, that times that. We've done these before. Minus 3 times y is minus 3y. Minus 3 times 4 is minus 12. Any like terms? The y's are like terms.
Y squared plus y.
Minus 12. Good. Now, look at, that's Tanya's working. She did y minus 3 times y plus 4, but Michael is doing y plus 4 times y minus 3. It's exactly the same thing. He should get the same answer, but he's multiplying the y by everything in the second bracket and then the plus 4 by everything in the second bracket. It's the same thing. So let's see what he gets. What's y times y? Y times minus 3? Minus 3y. Plus 4 times y, positive 4 times y is plus 4y, and plus 4 times minus 3 is minus 12. So y squared minus 3
1.
plus 1. Plus 1y or just plus y minus 12. They get the same answer. Now, we're not going to do it like this. All right? It takes too long. You make mistakes that way. I don't like that way. But you can see that it doesn't matter which, that's just showing whether you multiply, doesn't matter the order in which they're written, basically. So we're going over the page for the nice quick method. One more time. So we're going to do the long way one more time. The x gets multiplied by everything and the plus 4 gets multiplied by everything. We actually do it that way, but in our heads. The only difference is when they're writing that first line, we're not going to write that first line later. So the x gets multiplied by the x plus 5 and the plus 4 gets multiplied by the x plus 5. What do we got? X squared plus, what do you got, girls? 5x plus, remember that times that, plus 4x plus 20, which is x squared plus 9x plus 20. Now, I want you to have a look at something just to prepare us for tomorrow. Look at the plus 4 and the plus 5. What's 4 times 5?
20.
That's the constant on the end. And what's 4 plus 5? 9. That's the number in front of the x. Just keep it in mind. Okay, let's do the next one the way that they're doing it. Okay, they're going x bracket x plus 10 plus 7 bracket x plus 10. I'm not going to be doing this much longer. All right. So what do we get? X squared plus 10x plus 70, which is x squared plus 70. Again, look at the two constants. What's 7 times 10? What's 7 plus 10? All right, now, I don't want to do it that long way anymore. I mean, we can, but I don't want to. So what we're going to do, we're going to do the FOIL method. Who knows FOIL? FOIL. First, outside, inside, last. Are we ready? One sec. Some people use something called the FOIL method. So, F is for FOIL. F is for first. What's the first times the first here? Now, just listen really carefully. I want you to look up while I say this instead of copying. F is for first. So, x times x is x squared. What's the outsides? X times the n. So, girls, but I do it like that anyway. You start with the x and you multiply it by each of the things in the second bracket. That way the FOIL works anyway. Look, the x gets multiplied by the first one. The x gets multiplied by the second thing. Isn't that systematic? Take this one, multiply it by each of the others. So that is firsts. That's the outsides. What's x times n? X, n. Next one is insides. They're the insides, the m and the x's. Can you see? They're the outsides, they're the insides. Plus m times x plus lasts. That one times that one. Look, first, outside, insides, lasts. The last one's in each bracket. If you don't like doing that, what are the lasts? M times n is m, n. Now, girls, what are the like terms here? The x's. So we write this as x squared plus. Now, see how you've got nx plus mx? They're like terms because the x's are the same. I can factorize out the x, and what if I take out x as a common factor just here? N plus m plus mn. Now, what does that mean? You know how we were looking up here and we were saying, look how this number here is 20. That's 4 times 5. See how mn is the m times the n? Look how this number in front of the x is 4 plus 5. See, with the x, the number, this m plus n should be in front. But it's the m plus the n. Don't worry, we'll just keep going. We'll keep going. You will notice this at the end of the lesson a lot more. You don't have to notice it now. And it'll definitely be in your head tomorrow when you factorize. I'm just trying to let you see factorizing while we're expanding today. All right, girls, we're going to expand. You can FOIL if you want, or you just do it systematically. X gets multiplied by x, what do you get?
X squared.
X squared. The x gets multiplied by the plus 8. Plus 8x. Does this make sense? X gets multiplied by each of the ones in the second bracket. Yes? Make it bigger. Shh. The x gets multiplied by the first thing in the second bracket. The x gets multiplied by the second thing. We're done with the x. Now we do the minus 3. The minus 3 gets multiplied by the x. What do you get? X times x is x squared. X times 8 is plus 8x. Minus 3 times x is minus 3x. So I'm now doing the second term by each of the ones in the bracket. And minus 8 times 8, no, sorry, minus 3 times x is minus 3x, minus 3 times 8 is minus 24. Adding the like terms, x squared what? Plus 8x minus 3x is plus 5x minus 24. Again, girls, what's negative 3 times 8? Negative 24. What's negative 3 plus 8? Positive 5. See what I'm doing? You multiply, of course you've got to multiply everything by each other, but the two constants, when they get multiplied, will give you the minus 24. The minus 3 and the 8 get multiplied both by the x, and they'll be the term. When you do minus 3 plus 8, you end up with the plus 5 in front of the x. Let's look at the next one using the quick method. X times x is x squared. X times minus 15 is minus 15x. 2 times x is plus 2x. And what's the last one? Minus 30. Adding and subtracting any like terms, x squared what? Plus or minus? Minus 13x plus minus 30. Now girls, what's 2 times negative 15? Negative 30. What's plus 2 minus 15 minus 13? That one goes in front of the x. The number in front of the x is the addition of those two constants, and the constant term on the end is these two multiplied. This will come into, you'll see, you'll use that tomorrow. All right? Just try and notice it now. It's just going to help you with tomorrow. This is a special one. Girls, do you have this, or what did I go down here first? What's x times x? X times minus 3. So x times the first one, x times the second one, what have I got? Minus 3x, minus 6 times x, minus 6x, minus 6 times minus 3, plus 18. Girls, x times x times minus 3, now the second one, minus 6 times x, minus 6 times negative 3. What do we get? X squared minus 3 and minus 6 is minus 9. And plus 18. Girls, again, what's negative 6 times negative 3? Positive 18. Minus 6 plus or minus 3. So minus 3, 6 minus 3 is minus 9 in front of the x. The last one, for those that, what do we get? X squared, come on, minus 7x plus 7x minus 49. What cancels? Minus 7x plus 7x is 0. So it's x squared minus 49. Girls, that's called a difference of two squares. Okay, we'll learn about it later. Okay, so when it's identical things in brackets, one with a plus and one with a minus, the minus 7x and that plus 7x will end up being 0x, which is just 0, and you don't need to write it. Okay, girls, we're just looking here. Notice that minus 6, there are mistakes here. So you've got to fix the mistakes. So girls, what should the, what's the problem with this one?
Negative 6 and negative 6 times negative 6 is positive.
Yes, this should be a positive. That's the mistake. All right, what about the next one? Girls, just using that trick. What's minus 2 times plus 3? Minus 6? What's minus 2 plus 3? Girls, you know how the addition, so where's the problem? This is not minus x, this should be. So the middle term should be, this is just, you don't have to do it like that. Look, I don't even expand like that. I factorize like that, but let's just check the constant term. What's minus 2 times plus 1? Is the constant correct? But what's minus 2 plus 1? That's wrong. The plus 3x is wrong. If you expand it, you'll get x squared plus x minus 2x. What's the middle term? What should it be? Yeah, plus, no it's not. It's minus x. If you expand that, it will be minus x. The middle term should be minus x. All right, I think there's a few things wrong with the last one. There's lots of things wrong with the last one. What did they do wrong? What should the constant be? The constant is plus 20, and what's the middle term? Yeah, look, it's x squared minus 4x minus 5x plus 20. What did they basically do? Tell me in one sentence, one word. Like, you know, they mixed them up. The 20 and the minus 9 are swapped. Got it? Those numbers are correct. The 20 and the minus 9 are correct, but they've put them in the wrong place. So girls, you can just expand it yourself, okay? Now, we're just going to practice this one at the bottom. It's exactly the same. Okay, so let's do the first one. So this one, you cannot guess what the constants will be. Well, you sort of can, but you won't be able to guess the middle term. So you just do this the long method. What have we got? What's 2x times x? Constant's got no x term. A constant is just a number. So girls, a constant has no x. Okay, girls, what do we got? 2x times x is 2x squared. Shh. 2x times 7. So girls, same method. 2x times x is 2x squared. 2x times 7 is plus 14x. 3 times x is plus 3x. And 3 times 7 is 21. Okay, which is 2x squared plus what? 17x plus 21. You can do the other one there. What do you got? What's 3x times 5x?
15x.
15x squared. So girls, we're multiplying this next one. What have we got? 3x times 5x, 15x squared. Minus 12x. 3x times minus 4. What have I got next? Plus 45x. Minus 36. Girls, with this one, you can't guess the middle term. You can only do the constant, which is 9 times minus 4 is minus 36. What have I got? 15x squared plus 33x minus 36. Okay, now you'll still